All right, so here we've got another sequence that we're going to try to make another recursively defined function for. This time I did not list out the term numbers for each step, but we can still assume that this is starting from term 1, 2, 3, 4, and 5. There are certain situations where maybe we would want to start from a different place, like maybe calling this term 0, 1, 2, 3, and 4. But we'll encounter those more later on. For now, we're just going to go ahead and stick with this being term 1. And of course, when we write our recursive function, we need to tell people where to start from. So we're going to use a function. Now, last time I used function f. Here I'm going to use function p. Doesn't really matter what function name you give, as long as you stay consistent in the 2 lines of the function that you write. So this one says p of 1, meaning the first term in this sequence that we're calling p. And then I look at that term, and I see it's 200. So again, the first line tells people where the sequence starts. Now the second line has to tell people what to do to get more terms. So p of n, remember, was our way of saying the next term. Make sure your letter matches there. Whatever letter you used before for your function name still got to be the same. And n is our term number for any term we want to find after that first one. It's always got to equal something to do with the term before it. So I'm going to have that p of n minus 1 in there. That's pretty much consistent every time you write one of these recursively defined functions, is your second line is going to have the next term, p of n, and the previous term, p of n minus 1, somewhere in it. Now I have to tell what to do to this previous term in order to finish up this function. So as I look at these steps, a lot of people would say I'm dividing by 2, which you could use, but since we've talked about how it's better to think of these as multiplication for some of the stuff we'll do down the line with them, we're going to go ahead and call this a times 1/2 pattern, or times 0.5 if you prefer that. Every step, if it's dividing by 2, you could say instead it's multiplying by 1/2. So down here, when I come to this next term is equal to the previous term, I need to say that I'm multiplying that previous term by 1/2. Now you could put it in either in front or behind. Usually when we write multiplication, we put it in front of letters, like when we say 2x. So here I'm going to say 1/2 times that p of n minus 1. So there's my second line, except for my domain. I still need to give that part of it. Tell people when to use the second line. Remember, this is talking about our n's, our inputs, our term numbers. We started with term 1 up here. We didn't take 1/2 to get that one. That one was the one we were given to begin with. But then starting at term 2 is where we started taking 1/2. Take 1/2 to get term 3, take 1/2 to get term 4, and so on. So for all the terms that are higher than term 2, we're going to use that rule. So our domain at the end of that line says when n is greater than or equal to 2. And here is our completed recursively defined function.